So ladies and gentlemen, our notes today cover the distance formula. Okay, so basically if I give you a segment and I can't picture the segment or it's angled in any way, how can we find the distance between the two endpoints? Okay, the distance formula gives us the answers to those questions. So if we have point A and point B, then our distance formula looks a little something like this. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so we will need a calculator in order to figure some of these out, so just to make sure you have one. Okay, a few things to know about this formula. So can the distance be negative? Think about distance. Can my distance traveled be negative? If I am going to Michigan, is that a negative distance? The correct answer is no. So because the answer is no, if I somehow end up with a negative number, we did something wrong. Okay? We'll never end up with a negative number under the square root. Why? And the reason why is because everything is squared. Okay? Because everything is squared, nothing will be negative. Okay? Any negative number squared will always be positive. Okay? Does it really matter if x1 or x2 comes first? Yes. Follow the formula. Just follow the formula. And what happens if the segment is vertical or horizontal? So if I have a segment that looks like this, or a segment that looks like this. Okay? Well, if it's on the coordinate plane, we can count the distance. Okay? It makes our lives a lot easier if we can just simply count them. Okay? So, a couple examples for you. Says, find the distance between each set of points. Okay? So the very first thing I see, obviously, is a coordinate plane. I also see that none of my points are labeled. So the very first thing that I'm going to do is label those points. Okay, we always read our numbers from left, or our lines, I'm sorry, from left to right. So I know that this is point A, which means this is point B. And because I know those points now, I should probably figure out what the coordinates of those points are. So coordinate A, if I go -1, 2, 3, 4, 5, -5 up 5, and B has a coordinate of 1, -2. Okay, so now going back to our formula, says A is x1, y1, so here's x1, y1, and B is x2, y2. Okay, so now that I know x1, y1, x2, y2, I'm going to show all my steps. So guys, the distance formula is x2 minus x1 squared plus y2 minus y1 squared, all under the square root, just as a reminder. So now I'm going to take the points that I have and just plug them in. So x2 is 1 minus -5 squared plus y2 is -2 minus y1, 5 squared, all under the square root. So now I'm just going to simplify what's in the parentheses first. So 1 minus -5, so that's 1 plus 5 gives me a 6 squared, plus -2 minus 5 gives me a -7 squared. So I get the square root of 36 plus negative 7 squared is 49, which is the square root of 36 plus 49 is 85. The square root of 85 is 9.22. Let's round to 2 decimal places. Okay. Pretty self-explanatory. I think we just have to identify our points correctly and then plug them in. Number 2, we have points A and B. So this is negative 5, 1, and this is 4, 0. Okay, so we have the point x1, y1, x2, y2. And we just plug them in, guys. So the square root, and I'm not going to write the distance formula again because it's right next to me in the example, in example 1. So we're just going to plug everything in. So x2 minus x1 squared plus y2 minus y1 squared. Let's go ahead and simplify. So I have 9 squared plus negative 1 squared under our square root. 81 plus 1, the square root of 82. Oh, sorry, can't see. Square root of 82. 9.06. Okay, let's go ahead and look at example 3 because now we don't have a coordinate plane, so now I don't know where exactly these points are on the coordinate plane. So that's okay. All I have to do is recognize that the first point is going to be point A. So x1, y1. The second point will be x2, y2. Using that lovely distance formula, negative 7 minus negative 2 squared plus negative 7 minus 3 squared, all under the square root. So negative 7 minus negative 2 gives me a negative 5 squared, plus negative 7 minus 3 is negative 10 squared. Negative 5 squared is 25. Negative 10 squared is 100. So we have the square root of 125, and I don't know if that's a perfect square or not. It's not. When I plug it in, get 11.18 as a decimal. Okay. And number 4, x1, y1, x2, y2. So negative 1 minus 2 squared plus 4 minus negative 9 squared. Negative 1 minus 2 is negative 3, so I have a negative 3 squared plus 4 plus 9 is 13 squared under the square root. Negative 3 squared gives me a 9, And 13 squared is 169. I was off by a lot. 169 plus 9 is 178. If I plug that into my calculator just like that, square root of 178 gives me 13.34. Okay, now there is a small catch to the distance formula. Not every single time is it going to be as easy as plugging in the square root of 178 into the calculator and getting a decimal. Sometimes your answer will not be in decimal form. Okay, and that's where simplifying radicals comes into play. So we're going to simplify this. Okay. Our directions here say sometimes underneath the square root we have a perfect square. We'll get something that looks like the square root of 81 or the square root of 16, and we know that those things equal 9 and 4. When we plug those into our number or into our calculator, we get a good number. Okay? So we get numbers that aren't decimals. But what if I plug in numbers like 178, the square root of 178, and the square root of 125? We don't get a good number. We get some decimal thing that lasts forever and ever and always. If that's the case, then we need to take our square root and we need to simplify. Okay? So step one is to take the number under the radical and break it down into its factors. Okay, so we're looking for all the numbers that multiply to equal that specific number. Okay? If the factor appears twice, so if we have one pair, we cross out the pair and write the factor one time outside of the square root sign. Once I've crossed out all possible pairs, we're going to multiply the numbers outside the sign. Okay? And then whatever's left inside, we multiply those as well. When we're done, we check our work. The number outside multiplied by the number inside the radical should be the original number that we had. Okay, so let's go ahead, and that's a lot of words, so let's go ahead and look at 96. Okay, you guys probably saw this way back in the day, and your teacher might have called it a factoring tree. Okay, and so I'm going to take 96. I'm going to break it down into two factors. Okay, the first thing I notice about the number 96 is that it's even. So I know that the number 2 is going to be able to go into that. So 96 divided by 2 gives me 48. I can't break the number 2 down any farther than 2. Okay, but I can break 48 down into 2 and 24. I can break the number 24 down into 2 and 12. 12 can be broken down into 3 and 4. And 4 can be broken down into 2 and 2. Okay? And we want to do this until we stop and we run out of everything. Okay, so I know now, and I'm going to use my magenta e-colored pen, that all of these numbers right here multiplied together give me 96. 2 times 2 times 2 times 3 times 2 times 2. Okay, and I'm going to rewrite the entire problem, square root of 96, as all of these numbers. Okay, so we get 2 times 2 times 2 times 2 times 2 times 3. And the only reason I rewrote it with the 3 at the end was so that way I can see how many pairs of 2's I have. Okay? So ladies and gentlemen, that is step 1. Can't even trace a straight line. I am bad at this. Okay? So now, step number 2 to simplify radicals, if a factor appears twice. Okay, so let's go ahead and find all the pairs of 2's. So I have 1 pair of 2 and 2 pairs of 2. Cross out both and write the factor one time to the left. So I'm going to cross out this. I'm going to write it out here. And I'm going to cross out this, write it right here. Okay. Once all the pairs have been moved out, so now I'm going to rewrite this with whatever's left underneath. That should be a 3. I need more coffee. Okay. Now we're going to multiply everything. 2 times 2 is 4. 2 times 3 is 6. Okay. You know how I said step 4 was check your work, the number outside multiplied? Go ahead and cross that out. I don't know where that came from, to be honest with you. Okay. So this right here is my simplified radical. Okay. So I'm going to do a few more of these. I might not talk my way through them. So you can put me on mute now if you want to, but I'm going to solve them the same way. I'm going to create a factor tree, then I'm going to rewrite it, pull out the pairs, okay, and go from there. Okay, so 216 is even. $108 is also even. 54 is even. 27 is not. 27 is definitely odd, so let's see if it's divisible by 3. It is. And 3 and 3. Okay. So we have 1, 2, 1, 2, 3. So 2 times 2 times 2 times 1, 2, 3. 1, 2, 3. All under square root sign. Oops. So I have a pair of 2's and a pair of 3's. So I'm going to bring my pairs out. So I have 2 times 3. Cross them out underneath the square root once you pull them out. So I have a 2 times 3 on the inside. So I get 6, square root 6. Final answer. Okay. Ladies and gentlemen, if you look on the back page, if you flip this over, there are some practice problems for you. I want you to give them a try. Alright? If you want to see my answers to these two, come and see me in class. Alright?